Okay, we're going to use the diagram in front of you to illustrate what cutting planes are all about. So I'm using a color that I can use for both black and white. Suppose we have a particular integer programming problem, and when we look at the constraints of the integer programming problem, we get the area defined by P1. So this P1 is the original formulation. Now, so we have all these inequalities, but if you look at the fact that we need to have an integer solution, you will note that the only integer solutions that lie within P1 are these points here. These 7 points. And the LP is going to start looking at the whole area of P1 to try to find solutions, and it's going to take quite some time. If we can somehow shrink P1 to something which is smaller and still has the same integer solutions, then that is considered a better formulation. So P2, so now we're going to go to P2. P2 is going to be a better formulation. And the reason why we say it's a better formulation is it cuts off areas. We're not searching here anymore. We're not searching here anymore because there are no integer solutions there anyway. We're not searching here. Now we've added a little bit. We're not searching up there. We have added some little pieces to the search area, but it's generally better because it's smaller than the original. The best thing would be P3. P3 is absolutely the best. And it's called the convex hull of feasible points. If you take those 7 points and sort of fit a very tight set of linear inequalities around it, you have the convex hull, and P3 is best. And the reason why it's best, because the LP solution will yield an IP solution. So you can solve the IP with an LP, and you've cut down I won't darken all the areas that the P3 has excluded. So what the purpose of cutting planes is to actually find the P3 if it can, but get as close to it as possible. And this has become a really fine art in terms of how to generate better and better cutting planes and how to reduce the feasible region and eliminate non-integer solutions so that in the limit the LP will find the optimal integer solution automatically. And that's the story with cutting planes. We will not be asking you to solve any problem using cutting planes. We will not be asking you to solve any problem using branch and bound. But we will be asking you to formulate more integer programming problems. Integer programming is a very important part of the operations research set of tools. A lot of problems can be solved, can be formulated as very important problems, can be solved as formulated as integer programming problems. It takes quite a bit of practice to get good at formulating these problems, and so we hope we've given you a bit of a challenging set there with those 16 questions, and I urge you to try as many of them as you can, and we'll try to give you as much time, and we'll come back for the webinar very soon.